The universe just reminded us how small and fragile our world truly is. Astronomers are sounding alarms after recent observations of the interstellar object known as 3I Atlas, which appears to be on a trajectory that could bring it extremely close to Earth. First detected just a few months ago, this object immediately drew attention because of its extraordinary speed, size, and origin. Unlike the countless asteroids and comets we monitor within our solar system, 3I Atlas comes from outside, traversing the galaxy for possibly millions of years before entering our solar neighborhood. Now, scientists are realizing that its path is far from ordinary, and some early calculations suggest it could pass dangerously close to Earth, sparking urgent monitoring and debate across the astronomical community. What makes 3I Atlas so remarkable is not just its trajectory, but its interstellar nature. Its hyperbolic orbit indicates it is traveling too fast to be bound by the Sun's gravity, confirming that it originated outside our solar system. Interstellar objects are exceedingly rare. Only a handful have been detected in the past decade, such as Oumuamua in 2017 and Borisov in 2019. But 3I Atlas stands out because of its unusual velocity and its unusually bright reflection, which makes it easier to track even at millions of kilometers away. Early measurements suggest it's at least several hundred meters in diameter, meaning that if it were to collide with Earth, the energy released could be catastrophic, far surpassing the largest nuclear explosions ever tested. Recent calculations have heightened concern. Using cutting-edge computer simulations that incorporate gravitational forces, solar radiation, and potential outgassing effects, scientists have determined that the object is on a steep trajectory toward the inner solar system, with a potential close approach to Earth within the coming months. While there is no confirmed collision at this time, the models show a range of possibilities that cannot be ignored. Even a near miss could still have consequences: atmospheric disturbances, meteor showers, or small fragments entering Earth's atmosphere. The speed of 3I Atlas is one of the most alarming factors. Moving at tens of kilometers per second relative to the Sun, it far exceeds the speed of typical solar system asteroids. This high velocity not only makes it difficult to predict its path accurately, but also amplifies the potential energy it carries. Scientists calculate that a direct impact from an object of its size at this velocity could release energy equivalent to hundreds or even thousands of megaton bombs. To put that in perspective, the most powerful nuclear weapon ever tested, the Tsar Bomba, released energy equivalent to 50 megatons. 3I Atlas, by comparison, could release many times that energy depending on its final trajectory and size. Despite these dramatic possibilities, astronomers are urging caution. Space is vast, and small variations in trajectory could change everything. Non-gravitational forces, such as outgassing, when heat from the Sun causes volatile materials on the object to evaporate, can subtly but significantly alter its path. Additionally, gravitational interactions with planets like Jupiter could nudge it away from a direct collision course. Scientists emphasize that continuous observation over the coming weeks and months is critical to refine predictions and determine whether Earth faces a real threat. The scientific response has been swift and coordinated. Observatories around the globe, from the Atacama Desert in Chile to Mauna Kea in Hawaii, are providing real-time data on 3I Atlas. Infrared telescopes measure its thermal properties. Optical telescopes track its motion precisely, and spectroscopic studies analyze its composition. Understanding what it is made of is crucial. A rocky or metallic object could survive atmospheric entry and impact the ground, while a loosely bound, icy object might fragment and burn up harmlessly in the atmosphere. Each observation helps refine simulations and inform any potential planetary defense strategies. NASA's Planetary Defense Coordination Office has confirmed that it is actively monitoring the situation. While a collision is still considered unlikely, the scenario highlights the importance of planetary defense programs. For years, scientists have advocated for early detection systems and potential deflection strategies to prepare for asteroids and comets. But interstellar objects like 3I Atlas present a far greater challenge. Due to their high speed and unpredictable paths, unlike near-Earth objects, which are largely confined to predictable orbits, interstellar objects arrive from unexpected directions, leaving much less reaction time. Public attention has surged as well. Social media feeds are full of animated discussions, simulations, and amateur observations. Citizens are setting up telescopes, hoping to catch a glimpse of the mysterious visitor. News outlets across the world are covering the story 24/7, emphasizing the combination of scientific intrigue and the potential threat. Meanwhile, experts are working to calm fears by emphasizing that current models show a range of outcomes, most of which result in a safe flyby. The potential consequences of an impact, however, are sobering. Even a relatively small fragment could cause severe regional destruction if it reaches the surface. A larger object, on the scale of several hundred meters or more, could trigger massive explosions, tsunamis, and climate effects by throwing dust into the atmosphere and disrupting global weather patterns. This is why early detection and accurate trajectory calculations are absolutely critical. Humanity now has the technology to track such objects with incredible precision, but the stakes are higher than ever when an interstellar visitor is involved. The scientific opportunity is equally extraordinary. Interstellar objects like 3I Atlas offer a glimpse into other star systems, carrying material formed around other stars long before our solar system existed. Studying its isotopic composition, surface chemistry, and structure could reveal secrets about planetary formation, chemical diversity in the galaxy, and even prebiotic molecules. Observing 3I Atlas as it speeds through our solar system may provide insights impossible to gain from any other object, making it both a potential threat and an unprecedented scientific treasure. Even so, scientists stress the need for calm. While simulations and projections are essential, panic can obscure reason. Agencies are providing updates, but the situation is evolving rapidly. Every new data point could shift the projected path slightly, potentially eliminating or increasing any risk. The lesson here is that space is unpredictable, and even rare interstellar objects demand our respect, vigilance, and scientific rigor. Emergency planning agencies have also begun reviewing potential scenarios. While the probability of a direct collision remains low, simulations for worst-case scenarios are being updated. These studies explore atmospheric entry, energy release, fragmentation patterns, and potential impacts on populated areas. The goal is not to alarm, but to ensure preparedness, demonstrating that even rare cosmic threats can be mitigated with advanced planning and global cooperation. What makes 3I Atlas particularly fascinating is its rarity. Unlike asteroids, which number in the millions within the solar system, interstellar visitors are extremely uncommon. Detecting one offers not only a glimpse into the unknown, but also a test of humanity's ability to respond to unexpected threats from the cosmos. It is a reminder that Earth exists in a dynamic, ever-changing universe, where unknown objects can appear from the depths of space with little warning. The situation also raises questions about long-term planetary defense readiness. Our current programs focus primarily on near-Earth asteroids, whose orbits are relatively predictable. Interstellar objects like 3I Atlas, with high velocities and unknown trajectories, represent a new category of risk. Scientists emphasize that continued investment in detection technologies, international collaboration, and research into deflection methods is essential if humanity hopes to stay ahead of potential cosmic threats. At the same time, 3i Atlas has captivated the public imagination in ways few astronomical events have. Its interstellar origin, speed, and potential proximity to Earth combine into a story that is part science, part suspense, and part cosmic wonder. Amateur astronomers, educators, and enthusiasts are all tracking updates, highlighting the growing intersection between professional astronomy and public engagement in planetary defense. Even within scientific circles, debates are ongoing. Could solar heating cause the object to fragment unpredictably? Will gravitational interactions with Jupiter or other planets shift its trajectory away from Earth? Could fragments pose a greater risk than the main body itself? These questions highlight the complexities of orbital mechanics and why continuous observation is essential to determine the true risk level. As 3i Atlas speeds closer to the inner solar system, experts are preparing for months of intense monitoring. Observatories will coordinate worldwide to capture every possible observation, feeding data into sophisticated models that refine the object's projected path. In the process, humanity will learn not just about this particular object, but about the challenges of monitoring, predicting, and potentially defending against objects from beyond our solar system. For the general public, the takeaway is clear. Stay informed, stay calm, and trust the science. The odds of a catastrophic impact remain low, but the scenario underscores the importance of planetary defense systems and global scientific cooperation. Interstellar objects like 3i Atlas are reminders that the cosmos is vast, unpredictable, and full of surprises. In the coming months, astronomers will provide continuous updates as 3i Atlas moves closer. Its passage will likely be one of the most closely observed interstellar events in history, combining risk assessment with scientific opportunity. Whether it passes safely or presents a minor encounter, its journey will provide insights that could shape planetary defense strategies, scientific understanding, and humanity's perception of our place in the galaxy. At its core, the story of 3i Atlas is a story of awareness, preparation, and curiosity. It reminds us that Earth exists in a dynamic universe, that even rare cosmic events can demand attention, and that science is our best tool to understand and respond to these challenges. As the countdown continues, experts, policymakers, and the public remain vigilant, watching closely, and ready to learn from a visitor that traveled across the stars, just to remind us how small our world is in the grand cosmos. In the end, 3i Atlas is more than a potential threat. It is an opportunity, a chance to test our readiness, expand our knowledge, and marvel at the mysteries of interstellar space. Its journey is a reminder that in the vastness of the universe, vigilance, curiosity, and science are our guiding stars. As it approaches the inner solar system, every observation counts, every calculation matters, and every moment is a chance to understand the cosmos and our place within it just a little bit better.